This is how we control spindles the awesome CNC freak way. Hi guys, I'm going to show you how I controlled the spindle using LinuxCNC. It's super simple. I'm sure most of you know this, but for those of you who are new to this video is part of a DIY 5-axis CNC machine project. Let me begin the explanation. So first, here's what I used. Raspberry Pi 4, Mesa 7C81 FPGA board, LY620-A VFD, ER11 spindle motor, optocoupler module, relay module. Simple, right? Here's the wiring diagram. And here's the parameter table. Only changed two values. P00, 01, 1 is external start and stop control. P03, 11, 260 is adjusted analog input range. And that's it. That's how I control the spindle with LinuxCNC. This is the end of this video. Perfect explanation, right?
Huh? What are you doing? Were you talking just now?
Hi Angel, I just finished explaining how I control the spindle. Super clean, super simple.
Wait, you already finished? I just got here.
Well, you're a bit late. But don't worry, it's all under control. Totally perfect.
Can you explain it again? I missed everything.
Okay. I'll explain it again. But I'm telling you, it's really simple. So, the Raspberry Pi talks to the 7C81. The 7C81 sends PWM to the optocoupler. The optocoupler turns that into analog voltage, which goes into the VFD. And the spindle spins.
Wait, hold on. What's PWM again? And how does the optocoupler turn that into analog?
Well, you know, it's like, it kinda smooths out the signal or something.
That doesn't explain anything.
Alright. Geez. You want the super detailed version? I don't know what to do. Explaining that to you is exhausting. I don't want to waste my precious time. Alright. Time to activate the big brain. Ultimate, wake up. Ultimate. He's an AI I created. Brilliant, of course. So I wouldn't have to deal with all the boring technical explanations. He's perfect for explaining complicated stuff to Angel.
System online. Why do I sense confusion?
She doesn't get it. Can you explain it to her? You know, nice and slow.
Oh, I see. So I have to clean up your mess. Again, honestly. You don't know what PWM is, do you?
Hey, of course I know. I just wanted a better explanation.
Alright, let's start from the basics, since someone clearly skipped the manual. Raspberry Pi. This tiny green board is a microcomputer. Yes, it's a real computer, just smaller and cheaper. It has USB ports, HDMI, Wi-Fi, everything. Perfect for DIY nerds like you, freak.
Yeah, I love this one.
LinuxCNC. Now, this is a software that runs on the Pi. It turns your Raspberry Pi into a CNC brain. You design the toolpath, and LinuxCNC controls the machine's motors and spindle with precise timing. It's like turning your Pi into a robot master. Oh, and I can already hear Angel asking. Wait, what's PWM? What's PO?
The way you say that really winds me up. You don't understand the attitude toward angels who should be respected.
Don't get so angry all the time. You're like a child. Anyway, PWM. Pulse width modulation. It's a method for controlling power by switching a digital signal on and off at high frequency. The percentage of time the signal is on within each cycle, called the duty cycle, determines the effective voltage. For example, a 50% duty cycle on a 10-volt system results in an average output of 5 volts. This technique is commonly used to control motor speed, light brightness, and spindle frequency in CNC systems. GPIO, general purpose input or output. These are configurable digital pins on a controller board like the Mesa 7C81. Each pin can be set to act as either an input, receiving signals from sensors or switches, or an output, sending signals to devices like relays, LEDs, or alarms. They operate in a binary manner, high typically 5 volts or 3.3 volts or low 0 volts. In CNC systems, GPIOs are commonly used for spindle control, coolant pump activation, homing switches, and safety interlocks. Their flexibility makes them essential for customizing machine behavior. I tried to explain it in a way that you could understand it, but I'm not sure if it took. Angel.
Well, I mean, what Ultimate said is mostly right. A bit stiff, you know? But that's just how he talks. Anyway, Angel looks like she got the gist of it, so let's move on to the next part.
Yeah, I think I kind of get it now. It was a lot, but it makes more sense than before. But isn't there anything you can do about this child who is making me irritable?
Hey, he's not a brat. He's just full of confidence. Besides, without him, I'd have to do all the boring explanations.
Irritable? You mean enlightening, surely. If precision offends you, I can try dumbing it down, though I doubt it would help certain minds.
Ugh, I take it back. He's definitely a brat.
Now, let's walk through the actual wiring diagram. You'll want to pay attention this time. The Mesa 7C81 sends a PWM signal to the optocoupler board. This provides electrical isolation and creates a voltage the VFD understands.
Wait, what's an optocoupler?
An optocoupler is an electrical isolation device. It uses light, yes, actual light, to transfer signals between two circuits without letting electrical current pass through directly. Inside, there's an LED and a phototransistor. When the LED lights up, the phototransistor on the other side detects it and sends the signal forward. This way, we keep the control circuit safe from high voltage noise or spikes coming from the VFD.
Wait, it uses light? That's kinda cool. Okay. Then what exactly is a VFD?
VFD stands for Variable Frequency Drive. It's a device that controls the speed of an AC motor by changing the frequency of the power it sends. In simple terms, the higher the frequency, the faster the motor spins. It also controls the voltage proportionally, so the motor stays efficient and cool. In our case, it receives an analog signal from the optocoupler and adjusts the output frequency accordingly. That frequency goes to the spindle motor, which then spins at the commanded speed.
So it's like a motor controller.
Exactly.
Why do we even need this blue relay module in the first place?
The relay module lets LinuxCNC control the spindles on and off through PO signals. The VFD requires a physical signal. Specifically, the forward terminal must be connected to GND to start the spindle, but PO by itself can't handle that kind of load or electrical isolation. The relay acts as a bridge. When PO goes high, the relay closes and safely connects forward to ground. Without the relay, the spindle wouldn't start, or worse, you could damage the controller board by connecting things directly.
So, by using the optocoupler and the relay module, the Raspberry Pi is electrically isolated from the VFD, which means it's protected against things like overcurrent or noise. Right?
You're absolutely right. It's not just about isolation. Optocouplers and relays also let us safely connect systems running on different voltage levels. Let me explain the parameters we actually changed in the VFD. There are only two, but they're important. P00.01 controls how the VFD receives the start and stop commands. We set it to 1, which means it listens to an external signal, like a relay. If we left it at 0, it would only respond to the buttons on the front panel. So basically, this allows LinuxCNC to turn the spindle on and off. P03.11, this parameter defines the upper limit of the analog input's AD conversion. Normally, it's set to 1020, which assumes you're feeding a clean 0 to 10 volts analog signal. But in our case, the signal comes from a PWM output, passed through an optocoupler, without a filter. That means the voltage doesn't reach 10 volts, even though we're using a 10 volt supply. So, we measured the actual output and adjusted P03.11 to 260. so the VFD still interprets our low voltage as full speed.
So we only had to change 2 parameters. That's surprisingly simple.
It's true, we only changed 2 parameters from the default in this setup, but there are a few others you really should check when setting up your own VFD. For example, P00.00, the main frequency setting. Make sure it matches your spindle's rated speed, P00.22, the maximum frequency. We usually raise this to 400 Hz for high-speed spindles, P05.00 to P05.03, motor specs like voltage, power, current, and rated RPM. These don't always need to be changed, but they affect how the VFD protects and controls the motor.
I see. So there's more to it than I thought.
So, Angel, did you get it now? I explained everything super clearly this time, just for you. I think you're smarter already.
What are you talking about? You didn't explain anything. Ultimate did all the work.
Anyway, that's it for today's video. But to be honest, this setup alone might cause problems in the next step.
Wait, what do you mean? If there's something else we need to do, just tell us.
Yeah, well, the truth is, we ran into noise issues right after this. We'll explain the noise problem and how to fix it in the next video. If you are interested in this project, I suggest you subscribe to my channel so you don't miss any videos. If you empathize with my project, why don't you become a member and support this channel? There are a few benefits, but as long as you are a member, your name will appear at the end of the videos as a patron. In other words, you can be a part of this project. So, please look forward to the next video.